and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Ellie, and this week I'm joined by Rwayda and Laura to talk about the challenges of constructing undersea tunnels and an innovative new project. Now, fortunately, we have Rwayda with us this week, and she's a civil engineer, so I'm guessing you know a lot about this.
Well, I think I know a fair amount about it. Not a lot.
We'll take a fair amount, which is certainly more than I know. Laura, what's your interest in this?
Well, I'm not a civil engineer, although I have worked alongside different aspects of civil engineering over the years. But I came across this article about this huge construction project to create an undersea tunnel in China, which would reduce journeys times from an hour to just 5 minutes.
Wow.
Yeah, the tunnel's flexible and it's made from concrete, which I think seems like a bit of an odd thing. You don't tend to think of concrete as being flexible. But it also seems to involve lots of novel technology and construction methods that I thought, ooh, well, this is intriguing. I'll ask Rwayda about them.
Consider me intrigued as well. Like I said, I know nothing about this. So, Rwayda, how do you make a flexible concrete tunnel? And what do you need and why do you need to do this?
Apparently, in this case, they use this new technique when they would precast things on site. And that's why they have on-site lab. So precast concrete itself is not new, but the way they're using it here is new. So they do it on land, then take it on a boat, submerge it to the water, go again and get the next section, and the flexibility comes from joining these sections together.
Yeah, I read an article that said that it had some sort of a special bar, in inverted commas, because that makes it sound really exciting. It would transmit these shear forces. So, that's when you apply forces in opposite directions, kind of like tearing a piece of paper. From what I've read, transmitting those shear forces means the tunnel's less likely to fracture. So I guess that's part of what makes it flexible in a way.
Yeah, I think so.
And they said they also pre-stressed the concrete, which helped make it flexible, which from what I can gather means that they just stretched it. But I don't think that's anything new, is it?
I reckon they made it like sit a load of exams. Just made it really stressed.
Stress it out.
Stress it out before they put it underwater.
A good way of thinking of pre-stressed concrete, if you hold like a pack of books and press them together, you can add more books on the top of the pressed books.
Right.
And this is the whole idea of the pre-stress, because you're adding stress to a specific point within the concrete. And the idea of that concrete started in the 1800s. There are a lot of pre-stressed concrete now, but I think that the novelty here is in between using these shear bars that Laura talked about. I think these shear bars have joined the sections as well as joining within kind of the tube itself when they submerge it. And I think that would help the sections to be bonded with each other. This is my understanding. I'm assuming a lot because I did not find much information.
So if we take a little step back, this is the Dalian Bay Undersea Tunnel that we're talking about here with all these fancy new novel techniques and pre-stressed concrete. So why is this so exciting? What's the big draw for this project?
Well, it won Global Project of the Year, which I assume is a big thing in civil engineering terms. And I think that was partly because of the mix of first-of-a-kind technologies and also the new construction methods that they used. Because Rwayda was saying they had this tube factory on site. They kind of improved the construction as they went on site, so they could get the time it took to sink each section of the tube. They got that time down really, really short in the end. It was like a 4-year project, so they had quite a long time to iterate and improve things.
Yeah, and it seemed to have suggested first in the early 1990s, but was not achievable until now because of the location. One of the things I was reading about is how cold the water is around there, so it's really difficult to build, and that's why it's much more novel now. I think they needed a better techniques to build it.
So this sounds pretty sort of at the forefront of what we would call these engineering marvels, I suppose. So they've built this tunnel and it cuts down the time from getting from A to B. Instead of being 60 minutes, it's only 5 minutes. And it took 4 years to build. Do we know how long it is?
So it's about 5 kilometers.
So that's a pretty decent undertaking to build an underwater tunnel. And I have no concept of this, but you were saying that the water is cold. So, like, what sort of things are they doing on this on-site lab then to look at, like, how they're going to put it into the water?
Oh, well, I think they would have investigated how the concrete would react to that water, what type of bond you will have, and they would possibly be testing on site to see the effect of that. And I think we will also need to think about salt, right? Because it's sea, so it's a salty water. So that would also affect the concrete. So when we think of concrete, it's not only concrete. Concrete comes with rebar, with steel rebar in them. And once the salt gets in, they get the rebar to corrode, and then your section would fail. So I'm assuming they have done on-site testing to see the impact of the environment, including sea salt, including the kind of cycles of freezing and thawing from the cold water as well. The other thing they did, they kind of like digged the bottom bed of the sea, but then they have a full section of a tunnel submerged in. So I think that was also not an easy procedure to fit.
Yeah. I imagine that's very difficult. If they're looking then at the effects of the salt and all the things and they're digging into the seabed, were they then looking at the, like, surrounding marine environment and the foundations, or, like, was there anything done to prepare the sea floor? Or what other experiments might they have been up to?
They prepared the seabed, but there is no where they said that they dig in a foundation, which also I find strange. But they prepared the seabed, this is my understanding. Then they have their precast segments of the tunnel submerged to the seabed that they prepared.
I read something about a riprap layer, which I think is just a load of stones they put on the sea floor in some sections. Which would help level it and create the right shape.
Yeah,
I assume.
oh my goodness, I didn't even think of the sea floor as, like, not being perfectly flat, but, like, obviously why would it be? But if you've got a tunnel that's then going, like, wibbly wobbly up and down under the ocean, that's not what you want for getting somewhere quicker.
No. I'm not even sure that the sea floor is all the same type of rock, because the article I read mentioned some of it's on clay and some of it's on, like, hard bedrock as well. And that, surely they're going to react differently to different environmental stresses, right? So if there's a temperature change, one might expand more than the other.
Also, surely clay is a nightmare to build on, isn't it?
It is a nightmare to build on, and usually you try to avoid it. The other thing that this article got me to think about, what is the anchoring mechanism for that tunnel to stay in? You submerged it, but what is holding it down? You have air in it.
Yeah, we should stress, I think maybe we haven't made this clear, that this is massive. This is a 6-lane car tunnel. So this is not like some little tube to run, internet cables through or, gas pipes. This is like a 6-lane motorway essentially under the sea.
Yeah, and they're heavy tubes as well. I think each segment weighs, is it over like 7,000 metric tons, I think?
I think so, yeah, I read something like that.
I don't understand, right, forgive me for not being an engineer here. If you're making sections and you're sinking them into the seabed, right, how are you then connecting them so that the water isn't going through them at any point? Like, if you've got a section 1 and section 2, they've sunk, is there, like, a trap door that they then, I don't understand.
They said somewhere that the level of tolerance was 0.01.
A millimetre?
Wow.
Yeah, like the tolerance.
That seems tiny.
Yeah.
Yeah, considering how big these tubes are, yeah.
And also they said they use some kind of high-performing grounding material to fill the gaps so it will not...
let in the sea.
Yes.
I wouldn't be surprised if it started off with water in it initially, because they were building this in segments, right, and putting each segment undersea at a time.
Mm.
And then once they'd connected all the ends, they just pumped the water out. That's how I'd do it, but I'm not a civil engineer.
Surely that's a lot of pumping though, isn't it? As soon as you let the water in, I feel like you're on to a bad start.
I think they would have gotten some water in them, but I think they would have sealed it somehow to have minimum water in. Because if they let the water in that fast, that means they have not protected the connectors well. These connectors will have some steel showing up in them, then that would kind of, like Lego, blog in into the second side of the tunnel.
It's a giant Lego tunnel underwater.
Pretty much, yes. That's what they're telling us.
Well, maybe that was part of some of the on-site testing they did, because they mentioned 20 different experiments. So maybe part of it was looking at how they could grout it and keep it sealed. And they also had lots of sensors embedded into the tunnel and in the concrete, I think, so they could measure all these different parameters, which could include, is it starting to leak?
Yeah, I mean, that's surely the big thing that you want to avoid, is it starting to leak. I also read that they determined that it could last for 100 years.
So I think traditionally you build buildings to last 50 years. But I think if they designed it for 100 years, so that means they would have put in much more effort in having high performance concrete and all this fancy steel. The other thing that they mentioned is they use this prefabricated or manufactured sand. What they did is got a stone and ground that stone very fine, so it would fill all the gaps within the sand particles, which make it much higher performance. And that would make it more workable, so it's easier to cast, and also make it apparently more water resistant, so resistance to chlorides and more resistant to permeability, so it's like less water absorbent concrete.
It was a limestone that they used, wasn't it? You'd normally use sand, so that would be silica. So they replaced silica with calcium carbonate, so it's a very different chemistry, I'd have thought.
Yes, they have replaced the chemical component to provide more resistant to chloride.
Yeah. I mean, I'm glad to see that they were using the manufactured sand, they call it, even though it's limestone. Because we did that episode a while ago about are we running out of building sand?
Yeah, that's where it's all gone to the... But no, apparently not. If it's limestone, they've left it.
Yeah.
I would hope they have done long-term testing, because usually when you test concrete, you test 28 days. But in these projects, you would want to do some durability testing, and that would be you tested at 90 days and 120 days. So I'm hoping that they did some of that testing to certify that their concrete would be the same in 100 years, but I don't know how would they do this test and they build it within 4 years, unless they started the testing before and they already have some lab data. Unsure about the 100 years.
They looked at other undersea structures as well, didn't they, that had been in the sea for up to, I think it was about 86 years.
Oh, that's a good idea.
I assume they looked at all these different structures and how they were weathering and which components were weathering more slowly, and used that to say, if that's happening to these things, then to make something that lasts for 100 years, we can extrapolate and do this.
Yeah, and I think the sensors, because they said they have an intelligent center units, which I'm hoping, or I'm thinking it would be collecting data even on some of the chemical component of the concrete. It records some sort of chemical changes, and if it records that, they would know if there's something that they need to fix.
So that raises another interesting question then, like, if you're building it underwater, you've got everything down there and one of the sensors then goes off and says something's wrong. How do you even go about, like, fixing it underwater? Or are they using, like, cool systems to do this? Because I'm also then trying to imagine how they got these giant 700-ton pieces into the sea in the first place.
I think they will have similar procedures to go and fix it, but like placing a whole tunnel and fixing parts of it are two different things. I think is easier to fix little things rather than placing the whole thing. So if they could place the whole thing in and it's functional, surely they can go down and fix little bits. Like that's why these sensors are very important. Yeah.
Could you imagine seeing these incredibly heavy, very large bits of tube being floated across the bay, though?
No.
Now, how weird must that be? This massive thing that looks like it probably shouldn't float, but it's doing it anyway.
So that's what they did then? They floated these sections across the water to where they needed to be?
Yes.
Wow.
Mm-hmm.
How?
I hope like they do one of these mega structures episode on it, and I think they would, right? Because they would show you how they would have built it, because they will have videos and all of that, and I think that would be interesting. I'm really interested to see how they did actually do it.
Yeah. We'll keep an eye out for the documentary then. I mean, they said they used this special positioning system for their barges when they were putting, at least it might be the riprap layer rather than the big tubes. I might be misremembering this, but they normally would just moor these really firmly to the trench that the tunnel's going to lie in, and they decided they couldn't do that because it was too risky. So they came up with a whole new way of doing it that involved floating barges and this highly accurate advanced control system they developed just for this one purpose. So I think is pretty impressive. I'd like to think that would have other applications in the future.
Yeah, I'm sure that they could then give that to someone else to use for a different project.
I think this whole way of building tubes is novel, and I think it would be integrated to other projects because it's the first time they use this way of precasting something, then put it underwater. In the case of a tunnel, it's not the traditional way of building the tunnel.
No, so how are they normally just like you just blast out the surrounding rock underneath the seabed?
Well, it's a little bit fancier than this. So you have this huge drilling machines traditionally, and these drilling machine will go down and drill, and you would kind of support that. Then you start building your tunnel and the drill tube. But it's a kind of a heavy machinery way to do it, and that's how they build the channel tunnel.
I'm still disappointed in the channel tunnel. I feel like it should be glass, and you should be able to see the fish swimming over you when you go in it.
Yeah, you've got me thinking, how thick would that glass need to be, and how much water is above it? So how much pressure is it under? I'm not sure I would want it to be glass.
I'm imagining it like, like when you go to an aquarium and you have the like tunnels and then like sharks and the rays swim over you. That's what I really wanted as a kid, not some like concrete structure that you just sit in your car for however long.
No, but those aquarium tunnels, like the walls are a metre thick and it's only supporting like a few metres of water anyway.
I mean, yeah, it would have to be like scaled up 1,000,000 times, but still.
Yeah, I think we still don't have the technology to build that glass yet.
Yeah, okay.
It would be cool to see that as you're travelling along, though, see what the marine life is up to and are they looking at you.
Yeah, so surely when they did this, there must have been loads of like environmental factors and costs to consider. Is this a better alternative than just building a bridge?
Well, I think that the kind of condition at that location are challenging to build a bridge on it. Also, there is some reservation for the marine life, and that's why I think by doing this way and kind of placing things in sea rather than doing the normal construction way, they would have preserved some of the environment in that area. Also, the cost of it was actually high. I forgot the number. It's not on the top of my head, but what I was reading about that as well, it's really important to link one of these two areas to each other for economical growth.
Yes.
So I think they're thinking on long term, the investment will return by economical growth to the area.
Yeah, well, could you imagine if your commute is suddenly 5 minutes rather than an hour? It would open up all these new job opportunities that you probably wouldn't have considered before.
I mean, that would make your day a lot better. You suddenly shaved an hour and, well, I can't do maths, an hour and 50 minutes off your day.
Yeah, and I was reading for some of the commute, if you go around the bay, it's about 8 hours drive.
Wow. Okay.
So I think the hour is also like is for certain location they're talking about, but if you kind of like your total from these two cities, your total distance of travel or time of travel, if it's 8 hours and you chop that down to 30 minutes or so with the extra outside of the tunnel commute, I think that's actually would make people from one area works in another. It's commutable.
And clearly they thought like a lot of people were going to use it if they built a 6-lane car tunnel in the first place. You know, it's not just like a standard freeway. This is a pretty big undertaking.
And I think like though if they're targeting economical growth, you would want to build it big in the first place so you don't have to go again and add to it
and rebuild it and make it bigger.
Because imagine like if they had to go and do more lanes later on because it's gotten too popular.
That would be embarrassing, I think. And also probably incredibly difficult.
So I think that they just decided just to go big and
make it last 100 years and then you're sort of done with it.
Yeah. So I think that's the idea.
Would you be scared then? If you've waited 4 or 5 years for this tunnel to be open, are you the first one driving through it? Are you trusting the engineering and the stressed bars and all the concrete and everything? Are you taking the inaugural journey? I mean, I guess it's 5 minutes, but still. You could drown in 5 minutes.
I'd rather wait for someone else to try it. I have a feeling to it's similar to these weak bridges that they get you to drive on and around the rural areas.
Oh yeah, when it's a sign that says weak bridge and you're like, well, could we not just make it stronger?
It's like, how weak is it? Can you tell me? Like, that's how I feel about these things. Like, you tell me a weak bridge, and I'm an engineer, and I'm really having a problem with the weak bridge sign.
I don't even notice them. It's so funny that you say that, because there's been one, like, on the outskirts of the village where I grew up in my entire life, and to my knowledge that bridge has never been changed. Like, it can't be that weak. Everyone's gone on over it for my entire lifetime, so.
Well, it's usually, I think this usually comes with a limit, right? So it's a weak bridge for a lorry, maybe not for a car. But I think for me, I would feel better if they stop putting weak bridge and they say the capacity is X.
That's fair. How about you, Laura? Are you driving through the tunnel?
I'm assuming it's already been thoroughly tested, and if they've opened it and the public can go through it, then it must be fine. I just think given my safety background, it would be very weird to let the public go through something that hasn't been thoroughly tested. So I think I'd be fine with it.
I wonder, like, when they were done, if they were then like, oh yeah, we should probably open this now, or whether they were just enjoying the tunnel for a little while, just without any cars on it. I'm sure that they had costs to recoup. Is it free? Is it a toll tunnel? Do we know?
Yeah, I didn't find anything that says it is, but I would like to think if there's an economic benefit to letting people travel that they wouldn't really charge for it, but I'm just a nice person.
If Laura was in charge of the tunnel, you wouldn't be putting a toll on that.
There will be more information coming on that bridge, I think, soon. They'll open it, people will use it, and they will say how great it is.
Yeah, and one of the challenges I found when I was looking into this, a lot of the literature seemed to be only available in Chinese, which is fine for the people that built it in China. I would need a translator, so I was a little bit disappointed by that because I'm so fascinated by it. I wanted to learn more.
I'm still mind blown by the fact that you could build a tunnel underwater in the first place. Like, I understand the Channel Tunnel and blasting through the rock. Like, that makes sense to my brain. But still, I'm not fully on board with the floating giant pieces of concrete into the ocean and then dropping them and then somehow sealing them all together and making it work. But I'm very impressed that lots of other people understand how that happens.
But I guess you take flights, though.
Yeah.
So you have no problem with getting in a metal tube that's just suspended in the sky by physics.
That, for some reason, is fine for me. That makes perfect sense in my head. I'm like, it's just power. It's just power over, air resistance? Whereas this, upsetting.
Well, I think this is the next step in building and development. We started to see some 3D printed concrete structures coming up, and I think will become more. I've seen a construction site somewhere in the UK that they started to do 3D printed concrete houses.
Oh, cool.
I think build more efficient and quicker would be the engineering of the future, especially now with the reign of artificial intelligence and robots.
We'll get artificial intelligence to design the next, global engineering project of the year.
Ooh, I'm not too sure I like the idea of that. It depends how the AI's been trained, doesn't it?
Yeah, I suppose so.
From my little experience on seeing how people are using that in engineering, I would not recommend it. I meant artificial intelligence in terms of the monitoring and the sensors and the quality of the material going in.
Okay.
And necessarily in the design. You still need a human there, I think.
Yeah, if it could have taken all that historic data. You know, I said they looked at all of the undersea structures that have been around for a while and they figured out how to design something that would last for 100 years. The AI could probably have done that, I don't know, better or quicker or something.
Yeah, that's probably true. Give it a data set to work with, pre-train it, rather than letting it loose, perhaps, on a huge engineering project.
Yes.
Well, I feel like we've probably gone off topic just about enough. We've covered everything from how you might even begin to build something of this scale, what substances are involved, what materials you might need to use, and whether you'd even want to try it if you got the opportunity. So thank you very much for listening, and we'll see you in the next episode.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.